Okay, so I have to stop it right here because I want to talk about it, and we have two more problems we want to go before we close the class. Before we move on, the last section of your chapter is talking about which loop do we use. So we have for loop, do while loop, and we have a while loop. So anybody has any idea which one do we use? Which one do we start using?
For any problem with this one.
So what again?
So for what? Like, do we have to, what should we decide to, like?
When do you use for loop? Let's put it this way.
When you're calculating numbers with it.
When you know
Good.
the amount of steps you need to take beforehand, right?
Very good. So the idea, and your book is talking about this, is in your pseudocode, you don't mention any for loop, while loop, anything like that. You just say you're going to loop. Then when you take your design and you change it to code, at that time, you're going to decide which loop you're going to be using. So if I have a starting point and I have an ending point and I have some steps, the step doesn't have to be one, it can be more than one, then I'm going to use a for loop. So for my loops, I'm going to start with the for loop. Can I use the for loop? If I can use the for loop, I would use the for loop. The next step is, okay, I cannot use for loop because I don't have those steps. My concern is the steps and starting and ending. Then I'm going to end up with the while loop versus do while. The while loop, my suggestion is always use while loop. Never ever use do while. The while loop, it checks, and if the condition is not correct, it's not going to do the while loop. So we use that in validation. So if the number is entered is valid, I don't have to go to the while loop. I can just skip it. So while loop is going to skip if the condition is not correct. Do while is going to do it one time, then it's going to check. So repeating the program, do while, you run the program one time, then you ask the user if they want to continue, you do it that way. Same thing goes with the switch statement versus if-else statement. If you have a bunch of if-else statement, the question is, can you do it in switch? If you can do it in switch, you're going to do the switch. If not, you're going to use if-else statement. So your first choice for branches would be switch. Your first choice with loops is going to be for loops. Okay. Anybody want to share your founding for problem 8? Come on.
I'll go if you need someone to do it.
Okay, Daniel.
All right.
To your camera.
Oh, why is my camera off? No.
That's the question that I have for you.
Why is my camera not? Do you see me now?
No.
No.
Go ahead, share your screen for now. Then we fight over camera.
Oh dear. I thought it was working just a moment ago.
No, it wasn't working.
It was working. It totally
Yes,
was.
right.
Everyone saw me.
It was.
It was.
Okay, can you share your screen now?
Sharing it now. Okay. So here's what I've got.
Okay, problem 8.
Yeah.
What is your processing? Okay, once again, use the template that I gave you guys. The reason I want to use the template is everybody's going to be on the same page. So if I want to go to the processing, I can just jump into the processing. Please
Gotcha.
use that template. Okay, what is your processing problem?
I guess that would be this right here, I suppose.
Okay, create variables are not part of, please use the template.
Okay, sorry.
Okay, let's go to the next line. Loop with counter variable, adding -1 to, what is that? Power to counter?
Yeah,
and
to the power of
2
counter.
Counter plus 1 to pi approximate y counter. Okay, so you're writing your pseudocode as a programmer. So you're basically thinking about code. A lot of us do that. I want to take you back from it. I want to step out. I want to think about the code. And let me show you my option you guys don't have to do it my way. I just want to show you an option, and then you can make you guys think about it. Okay, I'm going to switch to my screen,
All right.
and then I'm going to talk about the way that I do it, and then we can go from there. So for number 8, let me go over these things. Okay, so number 8, in the processing, I said, okay, what is it that I'm calculating? This is what I'm calculating, correct? This is what I'm calculating. I'm calculating the pi. This is the formula. Now, can I break it down? Yes, I can break it down. Let me get my annotation. So what I'm going to do is I'm going to break it down in 2 sections. So my first section is going to be the 4 itself, and the second part is going to be my bracket or parentheses or whatever we want to call it. So that's the way I'm going to break it down. So that's the first breakdown. I'm going to break it to a multiplication by 4 and the rest of this. Now, inside the bracket, what do I do? I'm adding a bunch of numbers together. Even if it's a negative, I'm adding them together. So I'm basically creating a sum of these terms. I'm going to call them terms. Each one of them are terms. Now, I can break this down again. So I'm talking about sum of terms. The next breakdown for me is the minus that goes from minus, plus, minus, plus, minus, plus, and so on, which at the end is minus 1 to power of n. We can think about it that way. Then I have the fraction. And the fraction itself has a numerator and denominator. So you can see I'm breaking things down to the smaller pieces. Now I can focus on it. And in this part right now, I'm just focusing on the numerator. So for my numerator, it's going to be what? It's always 1. So if I skip this minus plus, my numerator is always 1. My denominator is starting with 1. If I put a fraction over here, if I put 1 over here, so it's 1, 3, 5, 7, 9. So technically it's going to be a loop starting with 1 and adding to it. Remember, I am focusing on one thing. Right now, I'm focusing on denominator only. I'm not thinking about anything else. I'm just thinking about my denominator. And the way that I like to approach things is I'm going to start in the middle, and then I'm going to check the boundaries. So the middle of this, I can look at these 2. Let me clear these. So in the middle, I can think about 2 of these things. I'm going from 1/3 to 1/5. So if I have a loop that is like I'm not going to write the for loop here, but I have a loop that's going to add 2 each time, which is a good candidate for the for loop. And then my numerator is always going to get 1, and then I have an alternative minus and plus. Now, when I have my numerator and I have my denominator, I'm going to divide them together. Whenever I divide something in C++, I have to check it to be sure it is not integer divided by integer. Because if I have numerator as 1 and my denominator as 3, 1 divided by 3 is, what is 1 divided by 3?
0.
0. So it's going to give me 0, 0, 0, 0, 0, and it's just going to give me 1. So I have to be sure that one of these is double. So my numerator can potentially be a double 1.0 instead of 1, to be sure I'm not going to get the 0. When I have it in breakdown and I have working on one piece at a time, then I can backtrack it and figure out what I'm doing. So for my fraction, I need numerator divided by denominator. I figure out denominator already. I figure out numerator. I can fix my fraction. And if it's integer by integer, I have to fix it to be a double. Now, moving forward, I said, okay, what about I just multiply my numerator by -1 every time I'm coming through here. So each loop, if I start with +1 and then multiply it by -1 and then multiply it by -1, I'm going to get what I want. So I don't really need to create a fancy formula to do it. I just multiply by -1 every time. And that's going to give me the same result than if I would use a power or something else. So That's what it is. Now, extra credit of problem 7 is basically the same concept. So I am going to be looking at any questions on number 8 before I go to number 7. So on number 7 is basically the same thing. So I have a sum of terms, and my terms have a nominator and denominator. Same thing that I was talking about there. I do not need to the alternative, so I don't need to multiply by them, but I have nominator and denominator. Now I got to focus on each one of them. So the question is, what is my nominator? What is my denominator? So I'm focusing on this part. So going from x2 to x3, my nominator is what? Is nominator multiplied by, how is my nominator changed from here to here?
By X.
By x. What about my denominator? My denominator is 2 factorial here, 3 factorial here. It's multiplied by what?
3.
By 3. So if I had 3 over here for some reason, then I could multiply by 3. So I'm going to create a loop. I'm writing the for loop here, but technically in my design, I don't have a for loop. I'm just going to say loop. So if I have a loop here, can you guys see my screen?
Yes.
Do you guys see your own pictures on the bottom of my screen?
A nominator one and denominator one.
Okay, so let me put it on this view. All right, so if I create a loop from 1 to n, that means I'm going to have some kind of loop counter that's going to go from 1 to n. And here I want it to be 3. So this is going to be 1, 2, 3. I'm starting with this one to have a 3 here. So in the denominator, I would take my denominator multiplied by the counter that I have. My nominator is going to be multiplied by x. So my nominator is a star equal x, which is the same as nominator equal nominator times x. Denominator is a star equal loop counter, which is the same as denominator equal denominator times loop counter. In this for loop, I call it count. So this is going to do it for me from starting x all the way down there without using those fancy formulas and not thinking too much. I'm just going with the simple stuff in there. So you can see almost identical. I have term, my term has nominator, denominator, and then I calculate my nominator, I calculate denominator, I divide them, I find my term, and then I create a sum to go and do that for me. So I said I'm going to start with this one. So what's going to happen if my count starts at 0? I'm trying to figure out this one over here. So if I do a 0, my denominator says denominator times loop counter. And if loop counter is 0, my denominator becomes 0. So the whole thing is going to blow because I'm going to have a division by 0. So that's not going to help me. I have to start with 1. Remember, I start with the middle. Now I'm checking the boundaries, the beginning and the end. So the beginning, I cannot do this 1 through this loop. So I'm just going to leave 1 outside, the way that I did it on the top that I left 4 outside. So I'm going to calculate the rest of this stuff, and then I'm going to add 1 after the loop. So if you want to do extra credit, that's for your extra credit. Questions on 8 and 7. Okay, I want you.
Sorry, I have a,
Question?
sorry, I think I did, but I think I forgot it. My bad.
I stay after the class. If you guys have any questions, we can do that. I'm getting nervous about the time for 11 and 13. So I am recreating the breakout room. Again, focus on the processing part only. Do not write the code. Just do the processing part. If you're doing the pseudocode is not the code. A lot of us that have some background in programming, we start with writing programming. I need to take you back. I want you to think about it without thinking programming. Okay, so I'm going to open it up. I want you to join with your lab partner to a breakout room and then start with 11 and 13 as fast as possible so we can go over it together. We don't have that much time left.
Yes.
Okay, so I have this situation that this area is not good. So I have to, for understanding the problem, is if the user puts any other numbers beside this, I'm okay. If it puts any number that has any digit of this, I either have to go up or down to give a suggestion for upper end or lower end. So for me to approach this, I said, okay, first thing I need to do is I need to divide my number. I mean, in my input, I'm receiving a 3-digit number. So I'm going to be sure that my input is 3-digit number. So if it's not 3-digit number, I'm going to ask again till I get 3-digit number. Now I have to take my 3-digit number. I have to break it down to each digit. So using a division and percent, remember, if I divide by 100 or divide by 10, integer divided by integer is going to give me integer. 385 divided by 100 is going to give me what?
3.
3. And 385% 10 is going to give me 5. So percent is going to be the leftover or remainder. Division is going to be the left side, whatever we have. So we're going to divide it. We're going to get the digits. Then we're going to check each digit with my 1, 4, and 7. If they don't include that, then I can just continue. That's why I'm going to have a loop. Again, I'm not supposed to say while loop here, but I'm writing it to just give you guys some hint about it. In your design document, you don't say those things. The reason I'm using the while loop is if this condition, whatever you want to call it, I have a valid that if it doesn't contain these things, it's going to be valid. If it's valid, I'm not going to go inside this loop. I'm going to skip over it. If it's not valid, I'm going to go into this. What do I need to do? I need to add 1 to my upper temperature. So I can potentially put a plus here. Remember, plus at the beginning is going to do what? It's going to add 1, then it's going to use it. So if I add 1 to the so if I have a Boolean, I can just put it as a valid over there, and then I can add my add 1 to my temperature, and I can continue. So I have 2, 1 loop for going up, 1 going down. I have to have them separate because as soon as I start adding 1 to it, if I don't have different variable, my temperature has been changed. So the temperature that I get from the user, I'm going to set it to my upper end and lower end. My upper end is going to be adding 1 here. I'm going to do the same process. I'm going to break it down to a smaller I'm going to break it down to the smallest. So I'm repeating this one again. So if it's not correct, I'm going to set the valid to false. If it contains it, I'm going to put it in false. Otherwise, I'm going to do this. So I'm going to keep doing this till it's going to be valid and it's going to get out. Then I have another loop just like this, but I'm going to do it with the lower end. The lower end is going to have minus minus. So this one has up plus plus. So two loop exactly the same. Difference is minus minus. The other one is plus plus. Now, after this loop, remember what I said. If they are valid to start with, I'm not going to go through this loop. So at the end of my program, I can check if my upper temperature is equal to lower temperature, or my lower temperature is equal to either case. That means what? That means I didn't go through my loop. That means my original number was correct. So I'm going to have some kind of an if statement. If one or two of these are equal to each other, I'm going to write down the original number was good, you're good to go. Else, I'm going to display the original number has to be changed to either the low temperature or high temperature. Okay, so that's for that one. I'm going to quickly go over the next one, but I think I'm going to postpone that to Tuesday because you guys, to be short. So I'm going to add another problem, and we're going to spend some time to go over these things again next week. All right, so the next one. So the next one, number 13, it has 4 conditions. So it's already broken down for me for 4 conditions. So the question that I have to ask myself, it says, okay, I have these 4 conditions. Can I create a loop out of these things? So I have the first one, it says all 4 digits are different. I have the digit in the 1000 place is 3 times the digit of 10th place. I have number is odd, and the sum of the digits is 27. Now, I can potentially create a loop for odd numbers. So if it's 4 digit, that means my number is going to start from 1000, go all the way to 9999. So that's my range. So I can potentially create a loop to go from 1000 to 999. Can you guys see my screen?
Yeah, we can see it.
Okay, so it says it has to be odd. So if I start with 1001 and I go to 9999 and I step 2, then I'm going to have all odd numbers. So that would be a for loop starting at 1001, going to 999 by adding 2 to it. So that's going to take care of my odd numbers. So I'm done with number 3. And then I have to check it for the sum of them are 27. Now there is another thing that I can potentially put it in my loop or figure it out, that my 1000 place is 3 times than my 10 place. That means my 10 place cannot be more than 3. So I can have 1101, I can have 1201, I can have 1301. Of course, this has to be 3 times bigger than that. I'm sorry, I got it wrong. So 3010. The next one is 6020, and the last one is 9030. I cannot go beyond these because the 1000 is supposed to be 3 times the 10, and 10 cannot go more than 3. So I can put that in the body of the loop, that as soon as I see my 10 goes over 10, I'm going to break up. Remember, you have break and you have continue. Break is going to go end your loop. Continue is going to go back to the top of your loop. So you can continue, then it's going to go back up. Another thing I can do is, instead of creating one loop for the odd numbers, I can make 3 loops. one would start with 1001. Basically, I cannot have 1001. My loop has to start with 3000 because the 1000 has to be 3 times the 10. So going from 1000 to 3000, I'm wasting the loops. So one can go from 3000 up to 4000, the other one 6000, the other one starts with 9000. And with the 9000 cannot start anything less than 9030 because the 10 multiplied by 3 should get me the 1000. So I can potentially create 2 loops in here or 3 loops instead of 1. That way my program is going to be more efficient. And then I'm going to be checking the other 2. I'll be done. I'm going to postpone